So there's various ways to scale up, right? So the pandas use C and presumably efficient algorithms to run as fast as possible, right? And we thought of task, which okay, what we're going to do is we're going to, use multiple cores on a machine or use a cluster. Spark is the same thing, right? It's okay, we're going to, if you run it locally on your machine, you can use all the cores and split the data up and run things in parallel. But there's another strategy one can use, right? On modern operating systems, right, may only have 4, 8, 16 gigs of memory, but the operating system will then map. If you need more memory, you can map that to file on a disk, right? Swap space. The problem with that, it's not going to be very efficient because the operating system doesn't know how you're going to access that data, right? And so it will do it for you, but it's not going to be very efficient at it. So the other strategy you can use is, okay, let's have an algorithm which efficiently understand how we're going to access the data and then swap the data in and out from the disk, right? So this article talks about yet another Python-based library which uses basically the same interface as the pandas, right, DataFrames, to do that. And it does it in several ways. One is instead of reading in 100 gigabytes file of CVS data, right, which is going to be, how can you do that? Because it's not very structured. So they use a different file format, right? And it's always hard for me to say because I want to say HDFS, right? No, HDF5. And that file format has several advantages. One is it can be binding, it's compact. You can store multiple data sets in the same file, and it's indexed so you can actually read pieces of it. Right, and so this article points out that, okay, we can now 100 gigabyte, and it doesn't matter how, as long as you've got disk space available, right, you can do things fairly efficiently and fairly quickly. So it's another tool set we should know about, right? And so you need to read the article, right? And it goes on, shows you doing various tasks and how many, only takes 3 seconds, right, to go through 1 billion rows and do this one operation. So the one way to make sure you know about it is, okay, do it, right? So this article, it goes through this data set and shows you doing various transformations, plotting various graphs, right? So there's data, looking at it, and they show you in real time, zooming in the data at different spots in New York City. Right, so it's focusing on Manhattan. And it's been done in real time, given there's over 1 billion rows of data, right? So it's been done on a laptop, so it's not, high performance desktop machine. So, it's another tool you should know about. And then, of course, it goes through and it does various plots. Figure out, in this case, it's the number of passengers, right? How many trips are taken by, that many passengers. And so assignment 2, I picked out, just like 4 different things he does. And of course, the article gives you it gives you the Python code to do it. And so that's not the issue, right? Because it's like, the issue is, okay, let's run this on regular Panda, DataFrames. Let's use Dask to break it up in pieces. Let's use this library. Let's run on Spark, and let's see what sort of performance differences do we get. Now, of course, the problem is I wasn't sure if everyone in the class has a spare 100 gigs or so on their hard drive, right? And so instead of taking the yellow taxi data, I took with the green taxi data, and that data set's only 10 gigs. Hopefully everyone got at least 10 gigs they can somehow scrounge up, right? Now that will have an impact on the analysis because some of you may have 10 gigabytes of memory, and so you can possibly read it all in memory at once, right? So that's the difficulty.
How do we measure performance?
In Python, there is I'm going to call it a macro, but they call it Python magic or something. There's a function called timeIt, and then it's Python to get the magic part. It's percent timeIt, or is it percent? What's that? Yeah, percent timeIt, and then the code you're going to call, and it will then do 2 things. It'll run that code and return that result, but also then print out how long it took. And the problem with timing things, particularly if it's very small, timing is not as accurate as you think. I mean, I think it's digital, so we should go be exact, but there's too much overhead to compute it exactly. So what time it does, it'll run it n times and then compute the average. Right, so like one of the last lectures, there was an operation that took like a minute and a half, and I ran time at the time, and it was like, well, I ran it 7 times, so it took 10 minutes. And I expect that no one has really questions today about this. Next week there might be a few questions, and the week after there'll be a lot more.
Can you scroll up to the top a little bit? Right, keep going. Here. Where it talks about the lazy evaluation.
Yes.
And also I think it says memory mapping. So I get the idea of the lazy evaluation. For the memory mapping, is that why it's in the
HDF5.
Yeah. Is that why it's in that file format?
Right.
So
Yeah. Right.
Okay. That makes more sense. I remember I was reading.
Right.
Yeah.
Now, we'll find that Spark also does lazy evaluation, right? So in Spark, what happens is there's transformations and actions, and one is completely lazy. So if you do this and this and this, nothing happens. It's just mapping out, here's what we want to do, and then when they give me the result, then, okay, it has this plan of how I'm actually, right? So it knows, they can plan from what's the most efficient way of doing this, right? And they also do things like in regular pandas, when you say, filter out these things, right? You get different new data frame, right? The problem with that if you start with 100 gigabytes of data frame and then you fill this amount and you have a 70 gig data frame, now, I mean, how are you going to keep them both in memory? So anytime you're selecting rows or you're selecting columns here, what's happening is, you're just having, right, an interface to the real data set to extract, I mean, basically re-indexing. So you're not creating new data frames as you go along. All right, so there are a number of different techniques we can use to scale up. A lot of people are really enamored with Spark, but it's not clear how many people really need that power. Particularly since you can rent space on a single machine in AWS with almost a terabyte of memory. And so that's a big data set you can load in, and if you use these techniques, right, to memory map it, well, how many people have, 10 terabyte data sets to look at? I mean, okay, any other questions? Okay, so on to Spark, right? So we need to install it. There's two ways to install Spark on your machine. Both ways you need Java 8 or later. The problem is there are two problems going beyond Java 8. One is Java 9, etc. They broke, instead of having one big monolith, big Java thing, there's a bunch of small ones. And so every time you run an application, there's a configuration you have to worry about. The other one is that Oracle now owns Java, and the license agreement changed with Java 9 and forward, and so it's not as open or available. Now, one way is, use pip to install PySpark. It's a relatively new feature. When you do it that way, you don't get all the functionality, and there's virtually no documentation on how to configure it once you've done that, right? And in the past, I've completely wiped out Anaconda and all Spark things, and then reinstall everything from scratch. I haven't done that yet. So when I tried installing this version of Spark, I couldn't access it. My configuration always pointed to the full set. And you'll find if you go online, 95% of all the pages you find on how to install Spark, I can tell you how to do it this way, right? You just go to the Apache Spark web page. There's a download section, and this is fairly old. The current version is 2.4.5, and you select that, and then you want pre-built for this. And that pre-built section is just to use the HDFS, which is a distributed file system, and then you download, basically a tar file. Then you have to unpack it, and then you have to set up some paths, right? And of course, the fun part becomes if you've got a Windows machine, the Windows compatibility for Unix-like applications is improving over time, but it's not quite as good as Unix, right? In Windows 10, Unix compatibility is supposedly that much better, but I don't experience. But you're a computer science graduate student, so no problem, right? And there's various ways you can run it. You can actually run this from the command line, and you type in, one line at a time. I don't find that particularly useful. So I run it in a Jupyter notebook. And to do that, there's some configuration you need to do. How you do that, the exact syntax is going to depend upon if you're on a Unix-based system, what shell you're running, because each shell has a slightly different syntax for setting up environmental variables. And then there's Windows. You need to set the Spark home to be wherever you've established, right, the download. And then you want the PySpark driver Python version for Jupyter notebooks and options notebook. And then you need a SparkContext home bin. And then you'll find plenty of people talking about this setup online. And we'll see later, shortly, there's SparkSessions and SparkContext. You have to be careful. Now, I'll warn you now, and some of you will panic about this. When you finally get to run Spark, you'll start to see this warning that unable to load native Hadoop library for platform. Don't worry. It just means that it turns out that your computer you're running is not using natively the Hadoop file system, right? I mean, it's not. There's some various large pieces, the Spark core, and the Spark core has this resilient distributed data set. That was basically the initial Spark, and that development on that has stopped. They won't say it's deprecated, they just say that it's mature, right? More recently, they've added Spark SQL. It allows you to do a bit more. In particular, if you really want to, you can use SQL statements to drive Spark. And they've got DataFrames. Of course, SQL Spark is built on top of Spark Core. So inside the DataFrame, there's an RDD. Now the interface to RDDs and the interface to DataFrames are different. And then there's Spark streaming, so you can stream data inside that, but they claim it's near real-time response. For some people, it's not good enough. There's also a machine learning library that allows us to do, regression and some clustering, some optimization features. And then there's We do things in graphs. So Spark Core, that's basically the old Spark. The Spark SQL is newer. So really, you want to focus on Spark SQL, not the core. So they also talk about the structured API versus the unstructured. The structured API is new. It's DataFrames, DataSets. Unstructured is this resilient distributed datasets. And so you're going to see both terminologies. You have to remember that you've got accumulators and RDDs, but you don't have them in Spark SQL. You got RDDs over here, but you don't have them over here, right? And it's newer and it's faster, and it does more. So the basic structure here, which I stole from their documentation, is right. A SparkSession is a driver process, right, that a machine will run, and then you get a bunch of other machines that we're going to use to execute, which means we also need a cluster manager because we need to access where the machines are, which machines are part of the cluster, when a machine is busy, not busy. And then the SparkSession interacts with this. So here's your task. Right. So we've got the code rewrite. We've got the SparkSession, which sort of directs it. Cluster manager makes sure low-level stuff works correctly. Now we can run it in local mode, which is what you're going to do on your local machines. And you still get the SparkSession, you get the user code, but now you're talking directly to separate threads on separate cores on your machine. And yeah, we want to use it to deal up first because it's local, it's easier. Now another terminology, there's the SparkContext, and that's the old entry point into old Spark. And it, in connection to the cluster or local threads, it runs in the master node. It's basically your entry point into the whole system. And you want to stop it when you're done, right? The one advantage Hadoop had over Spark is that Hadoop, when a machine was done with this task, it will then tell the cluster manager, like, this machine is now available for someone else. Spark, what happens is all the machines you get are under your control until your program is done. So until you call stop, right, you're still running those, control those machines or those threads. All right. And then there's, each way of using Spark, different languages have different packages to access that. And there's SparkSession, which is now, right, the entry point we use for the new Spark. Now, of course, like everything else, the new Spark, the old Spark is underneath it, right? So the SparkSession does have internally a SparkContext, and you can get this context. And so the big data structure, right? So old Spark RDDs, new Spark we've got datasets and DataFrames. And DataFrames have rows and columns and have labels, and it's like, okay, just like the Panda DataFrames. And so, yeah, the RDD divides your data into partitions, and each partition is going to run on a different machine. And it's called an RDD, resilient data, right? It's because it's distributed. That's one of the D's. Resilient, because as soon as you're doing multiple machines, all kinds of problems occur, right? Because you have to worry about what happens when the machine goes down. What does it mean for a machine to go down? Is it down or is it just slow? If it doesn't respond in half a second, does that mean it's just crashed or not? Don't know, right? So one problem is, what does it mean for the machine to die is, but really it's like, okay, how long are we going to wait for any response, right? And what happens if, okay, we decide it's taking too long, we're going to ignore it, what do we do? Well, if you divide your data set into 10 pieces, and each piece is on a single machine, the machine is now available, you're screwed, right? So they replicate, right? They divide your data into partitions, and they send each partition to more than one machine. So if one machine goes down, there's another machine that can take over. So that's what the resilient, right? So, like I said, there's two types of things you can do, the operations we can do in Spark, divided into transformations and actions. And all the transformations are lazy, right? You say, select this, select that, filter this, blah, blah, and nothing happens. All that happens is you're building up a plan of what should be done so that the Spark can efficiently organize the operations you want to be done. Right, so all these map, filter, all this sort of stuff, right? Group by, don't happen when you call them. They happen when you call an action. And basically an action is, give me the answer, right? And then we're going to look at those, all the plans you've built up for those transformations and execute them and return the result. Right, so reduce, collect, count, first, take. These are sample actions that return results to the master node. And they will execute the plan you build up with all your transformations. And yeah, you go with the documentation will tell you which ones, here's a list of actions, here's a list of transformations. This is a Scala API, but we can do the same thing with Spark or Python. Yeah, so we need to understand these answers to these questions, right? What are they? What they do for us? When to use when? DataFrame is they're pretty much the same whether you're in Python, Pandas, right, or Spark, Julia. The table with the rows and columns, and you have labels, right? And each row is a row object. And each data frame has schema, so you know what labels are and what they call each column type is. And this is one of the things they added to the new Spark, is that the RDDs were unstructured, which meant they're like, you could put anything any type of data anywhere you wanted, and so they had no idea, Spark had no idea what type of data was in there, which meant that it took more space to store it because you couldn't say, oh, these are all ints, these are all floats, these are all this, right? It has a partitioner to divide that data frame, right, into different sets. And also the plan. This is how are we going to, you decide you want to do all these transformations on it, and as you add more transformations to that data frame, Spark is building up a plan, and you can actually ask, give me your plan so I can see what you're finally doing. And then there's what they call a Spark Catalyst Optimizer to actually look at that plan and analyze it and figure out what's the efficient way of executing that plan. And they are different, right? When you get a Spark data frame, it's not the same thing as a Panda data frame. And if you want to then use a Panda operation on it, you have to convert it from a Spark data frame, right, to a Panda data frame. And there's now a way of actually calling a method on a Spark data frame to convert it to a Panda data frame. The data set, the difference between a data set and a data frame is that the programmer can specify what the row is. So you can build a class that represents a row, but you only get to do it in the JVM languages. You don't get to do it in the Python world. And the RDD is unstructured. There's no type information available. You need basically about the same thing you do in the data frame. But here's an example where an RDD on the same data takes 33 megabytes, and a data frame, same data set, takes 7.3 megabytes, which that's a significant drop in memory. And now if you've got a 2 gigabyte piece of data, it's going to make a big difference. Okay, why the strictly JVM languages? Because you implement a class that is going to represent a row. And the problem with Python is a Python class does not exist in the JVM, and Spark runs in the JVM. So this is one example where Python are second class to Java and Scala and Spark world. Another issue is, Java was designed as a general purpose programming language, right? And so the data types, the way you represent them in memory, were optimized for that use case. But Spark's use case is very specific. And it's very important that we be as space efficient as possible, because the whole reason for Spark is to look at big things, right? So Spark does not use the built-in Java data types, right? They implement their own data types to be more space efficient and cache aware, so that and then we get into this problem. Most of the time you can ignore it, but you may be reading data in Python, and you've got a certain Python data type, and you're going to ship it over to the JVM, and you get something back, right? What types are mapping to what? And here's sort of a table representing what you can map to. Again, you're probably getting tired of me saying this, but there's the old over here and the new here, and this is unstructured and it's bigger and slower. This is newer, bigger, shinier, right? So focus on the shiny thing and not the dull thing over here, right? And again, the language is typed versus untyped. Typed is a new shiny thing in front of you, like, oh, look at the shiny thing, right? So start using some examples, and they're going to use this data set for a while, and it's just flight information, and it's JSON, where it came from, where it's going to, how many flights, right? So it's just very simple: origin, destination, how many flights. And then, okay, I want to read it, and so there's, let me quick go to a different, let me go, so here, standard Jupyter notebook running Spark, and so I'm connected to the Spark version I downloaded, from the Spark site. So I need to import PySpark, and then I'm importing random number, and then I need an entry point, right? And so I'm asking PySpark to give me a SparkContext. Remember, SparkContext is over here in the old, dull, terrible, disgusting corner. But I'm using it because it allows you to write a simple program without worrying about any data structure. So it's just, and this is sort of like the whole world of Spark. You're going to compute pi by just doing a random simulation. You basically, like with a circle, and you're going to generate a bunch of random points, and the percent of points which are in the circle is going to help us compute pi, because you do points that are units from -1 to +1 right? The percent of points land inside the circle will tell you, right, the area, and once you know the area is 2 pi r, right? And so all you're doing is, I'm going to compute 100,000 samples, and then you got a function called inside. So it's like, okay, is it inside the circle or not? And then what we're going to do is I'm going to call parallelize, which is the old, way of, executing code on multiple machines. And I'm then going to create a range, so it's 1 through 100,000, and which basically gives me, and then I call filter on it, which basically allows me to, run inside 100,000 times, and that is count, right? And then pi is 4 times that divided by the number of samples, and when I print out the results so I can see it, then I call stop so I can right. And that particular one was not very accurate. Right, and then you could do things with, so here I got the SparkContext and using version 2.4.5. You're going to see this a lot. You can specify how many cores you want to use, and the asterisk means use all of them. If you're running on a cluster, then you have to specify which machines you want to use. Now the SparkSession, right? This is the new entry point, the new shiny stuff, and so it's a little more work to set up. We have to right. So first of all, I'm importing from PySpark.sql, and that's right. That is the new version as opposed to the old dusty version over there, and then I create it. And of course, I can't directly run that same program on the Spark session because it doesn't have that feature. And so to run the program, what I have to do is merge it on the context. And so I get the context of the session, and then I can call parallelize on it. All right. So the reason I'm showing this now is because we need this SparkSession to do anything, right? That's the entry point. And so here's how we get the SparkSession. And now if we go back, now I'm assuming I got the SparkSession, right? And now I can call read on it and then read a JSON file, and I pass in, the path to that particular file. And then I get a DataFrame, which is exactly what you're doing in Pandas, right? You call read on it and get the DataFrame, and now we start doing operations. And then I'm, give me two, take two. Now, I also tell you, remember there's transformations and there's actions, right? Transformations are lazy. Well, that's a transformation. It's lazy. You don't read the file until you say in action, right? And this is going to be important because you have to be careful. What will happen is you're like, okay, I'm going to do this, 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 and this. So I read the file, this, and then I call, some action to get the result, and then you do some other stuff, and you call action again. It's like, but what you're used to is when you're doing the pandas, you call read, it's done right away. And so you're not reading the file again, right? But here you're like, okay, you only read the file, right, when you do the action, and it's not cached. So there are times when you might end up reading the file over and over again because you haven't really saved it. Right, so this read is lazy, right? And it's not until we call take that we actually do that. We actually read it, and then read the first two. And then if we call explain on it, we get the plan. Not very interesting, but again, we can look at the plan, and this is what it's going to do when you call an action on it. Right, again, that read is lazy. Take this says, give me, when you say when you say take two, it says, give me the first two rows of that data frame.
Oh, okay.
This is short, yeah. Well, but we have to be careful about precise. Remember, first of all, this data frame doesn't exist yet. And if we're using multiple machines or using multiple cores, right, and if data frame is big enough, it is going to exist on different machines or different cores. And then when you call take, you're calling from the master, and it's going to get this, in this case, the top two, and bring it over to the core or the machine that the master is running on. Now we can access it there. Yeah, eventually, yes. But the key thing to understand is, and the pandas, right, when you say give me the first three or n rows, I forget which function you call, but you're just like, all you're doing is you've got a data frame and you're showing the top two rows, right? Here, there's a lot more going on because you're not even reading the file until you call take. And you may be grabbing it from different cores or machines to bring it back to the master.
So it'll read in the whole file, 2 lines, the number of lines.
Right, yeah.
So then how do you prevent yourself from, I mean, you basically have to make sure you save that data into an appropriate data frame. So you have to continue to read in.
Right, there's a way of basically saying save this or make it persistent. And then we also have, a show does the same thing, right? But it gives us, take just give me the first two rows, right? Show does a sort of,
Nice.
yeah, it shows you the structure, right? Here's the columns, here's the labels. And again, the plan. Right, and that plan is stored, right, with a data frame, because if you want to do it again, it knows how to read, right? You can ask for the schema to figure out what data type it thinks it's using.
So right here then, you need to flight data dot sorted data take, you need to show, reading in all that data each time. You already have it.
No.
So you are rereading it each
Yeah.
time?
Yeah.
That what's the result being, what result is being saved into sorted whitespace?
What do
It
you
is,
mean?
it is a data frame, but it's a data frame that gets reformatted by reading in all the data and formatting that data frame in the same way.
Here's a plan, right?
Oh, I see. Okay.
There's a plan, there's a file, and then there's a sort. The sort is lazy.
That's just building up.
You have a plan. And so what's important is we have to understand what's an action and what's a transformation. All transformations are lazy.
So on here, what is
Yeah, I'm not sure, but it's part of the sort somehow.
then when you use sort?
Well, I'm sorting in the on column count, right?
Oh, okay. Oh, based on
Right.
okay.
Right. Any other questions?
Can you specify something?
Yeah, of course, yeah. Right. And look at the schema, and of course, if you're reading JSON data and or CSV data, it's guessing which data type to use, right? And so there are, so that, there's the name of the field, data type, and whether it's nullable or not, right? So there are ways of specifying what the schema should be to make sure it's right. Okay, so far so good. So more detail, right? I mean, so we can read, call read on it. And I mean, I'm just getting the read object, right? Now I can start specifying properties of that read. There's a header to the file. Okay, infer the schema, and now I'm reading it, and now I can show it, right? All right, in the file, I just create a simple little file just to repeat something. And then the data set looks like this, right? Right, and we print the schema. And again, you have various options that you can set. I mean, it's nothing, right? You expect most of these, right? And then, okay, I mean, you do all the same operations all over again, right? How do we set columns? Well, it's just select. We can also, call select and give it column function, then give it the name. And you can actually, use column spelled out. And so now, I mean, okay, I'm selecting the column, and I'm adding 1 to age for the second column. And so now I'm getting when I execute that plan, when I call show, right, I'm getting, you know, 2 columns, one of the name and one of the age increased by 1. And of course, I mean, Scala has some shortcuts we can take, which we can't do in Python. So here, you know, I have to call, you know, column function and add one. In Scala, I can just say, you know, here's a column name and do this operation on it. So I'm calling a column function. You know, so again, there's slightly different interface with the languages. Right. You know, so you know, Scala has more options. You know, we can shortcut things more. Right, calling the filter. Right now we're giving. Now you have to remember, right? When I create adult, it's all lazy. When I call show on it, like there's a, in reading the file, there's right the filter. You know, we talk about the push filter. So it's again, when I call adult show, I'm reading the file again. I'm performing all the operations to get to older, and then perform the operation to get to adult, and then right. And again, we start, you know, operation we got by Panda, but they're, you know, it's group by and right. So we can, if you want to save a data frame to disk, right, we call save on it. And I want, okay, I was only using one core here. So when you write it out, you get one file called success. I mean, it's an empty file, but it tells you whether it failed or not. And then for each partition, you're going to get a different file. Right? So if when you're in AWS and using 10 machines, you say write this data frame out, you're going to get 11 files. You know, one say success or not, and then a file for each of the machines that the partition was on. And we can use SQL, right? So it's like, okay, you know, I'm going to create well, if you use the SQL, right, you can create views on a table. So you can think of this as a view on the data frame called people, and now I can, right, basically, you know, SparkSQL select regular select statement or SQL statement on that view, and then I get the result, right? So literally you can just, pretty much everything you do in Spark, you can just create your data frame and then get the view on it and then start executing SQL statements. And there's basically no performance hit in doing that. But again, all that's happening here is Spark is going to take that SQL statement, right, and build up the plan, right, basically map it to its internal operations when executed.
Put multiple SQL statements in a single call.
I believe so, but I have to look it up. Yeah.
I'm just curious. If it would create a plan based around those two SQL statements that separate.
They'd be part of the same plan.
Yeah.
Right, so show is just basically to see what's going on, right? Collect is a action. And so when I call collect, right, I'm getting results back on the main node, and now I can look at the results. I can do things with them. But here, right, all this is being done on the master node, not in parallel on cores or multiple machines. Right, so this is basically, right, you build up this plan, and then you look at what's going on. Analyzer resolves it. The optimizer then creates a optimized plan on how you distribute data and how you do operations. So looking at, okay, the JSON file, reading the file, again, it's just, Spark read, format, blah, blah, blah. We're getting a long type for the age. Do we want that or not? So here's how we can actually specify what the schema should be. So I need a structure field, structure type, and all the various types. And now I'm creating the schema, right? Field first, right, should be a string type. Last, right, string type. Age is integer type, right? Remember the true or false is whether it's nullable or not.
Is this the same for this?
Yeah, I just have it. Yeah. And so here, first name, last name, and then the address. So when I read the file in, I'm not getting the age. Because again, you said, here's a schema, and I don't care about the age. So if you come across it, just ignore it. And since you said address, there's no address. it's all null. And if you say it's not nullable, then okay, you're gonna get there. So here, right, you have a file with all times. So you've got the time, the date, and the time, right? And again, I'm saying in first schema, and there's a separator is a tab, and you don't see it here because the tab is, and then it reads it and write it. It's reading it. It's figuring out there's a timestamp there, and it actually converts it into a timestamp for us. Which is nice, right? Again, you get tired of me saying this, but right, transformations are lazy. They're done on the worker machines. Actions pull the result back to the master. So you add rows, add columns, remove rows, change rows, and transform. We can change order rows. We can change it within the row, in the column. The actions collect just, says bring results. Count again is just how many. Describe first. For reaches, again we could pass in a function and it's going to apply that function to each thing, right? So it brings it in, applies the function. For each partition, operate that function on each partition. Some of the actions we can perform. And it's just a whole list of many that make sense. I mean, filter, group by, we can intersect them, we can join them, aggregate things, order by, a whole long list. And so we need to understand what things do, and of course we'll look at some of them, but then the rest, like, there's online documentation, and you're gonna bookmark it and go back and forth. Some more things we can do with DataFrames. 2 pandas. All right. Do JSON. So the number of quite a few things we can do on DataFrame. Drop NA, right? Now, one thing you have to be aware of in pandas, right? When you like compute an average or mean of a column, and there's rows that don't have, or have nulls or no data, pandas, okay, no problem. We'll throw this out for you. Other systems don't behave the same way. And you have to okay, are there any, drop all the first, and now we do the count here. Again, going back to the flights, origin, destination, count. Selecting, right, there's various options. Select everything, select a particular column, select, you can transform a column, keep it as is, rename it, right? So here I'm, doing a select, showing, right? So pandas, we can do column, and expression. Other languages we can get away with other type of syntax, but restricted here with Python. So we can start doing some, basic comparisons, numeric operations, comparisons. Right, so I'm, selecting, this column, that column, and then this column, new column transformed. Right, so the big takeaways are there's the old Spark over here. It's getting dusty in the corner because no one uses it anymore. The new shiny Spark. You get transformations and actions. Transformations are all lazy. Actions actually bring results. Make those transformations occur and bring results back to the master node. And then there's the sort of standard Panda stuff we can do, like things we do. But of course, the syntax is going to be slightly different. Right? So if you haven't already done it, you're going to want to try and install Spark and bring all your trials and tribulations to the class on Tuesday.